Okay, so you've all been working really hard. It's time to get some support. And what we're going to be looking at today is what we like to call support libraries. And these are tools that we're going to be using to help us in a lot of the different things that are going to happen. So for example, we may actually be looking at different hard complex calculations or generating random numbers and all sorts of fun things like that. So what we're going to be doing today is we're going to start by looking at something called the math library. And the math library is an object. Now we already know what an object is. We've talked about it before, but an object, just to re-summarize, is something that has a collection of attributes or data and a set of behaviors, functionality, methods that it can perform. So we talked about how a person is an object, and it has the attributes of like its eye color, its hair color, its height, its weight, its name, all that kind of thing. And it has different behaviors that it can perform: eat, sleep, poop. And we've also seen other objects while we've been programming, like the system object, which eventually allows us to do like println and stuff like that. Okay, back that up. Now what we're going to be looking at is the math library, and the math library is just a massive collection of functionality, and I mean massive. It has one main property, one main attribute or piece of data that we actually care about, and the rest of it, all we care about is its functionality. What is that main piece of data it has? Pi. It has pi to a significant number of digits, and we can access this by typing in math.pi. Now, you may be like, well, why don't I just create my own or just use 3.14? Because this is a lot more precise and it already exists. So why reinvent the wheel? Use what already exists. So you might come up with you might create a program, just ignore what's here for now for a second. Let's say I create a program and it has double radius, and let's say that is 4.3, and I want to calculate the circumference of a circle, double circumference. So how could I use that pi? Well, I could just say, well, circumference is equal to, 2, because the formula for the circumference of a circle is 2 pi r. So 2 times math.pi times radius. And now you can see that we're using it very simply. And now I could display that information if I wanted to, whatever I wanted to do. So I have actual use for this math.pi constant. Great. That's fantastic. Now let's get into the meat of it. Let's get in and talk about the functionality that the math library has. And it has a lot. So I've made a list here of 11 main methods that we're going to use. There are more. There are many, many, many more. And where can you find those? If you go to this link right here, this will take you to the document for the actual Java programming language, but specifically for the math library. And it will show you everything and anything that is possible, even with some code examples most of the time. Just click on it and you'll get what you need to do. Sometimes it may be a little bit difficult to follow and you might have to Google a little bit further to find some more examples, but you'll figure it out. So let's start going through these one at a time. So what can we do? Well, the first thing we can do is we can round values. So if we pass in a float, as we talked about before, a float is nothing more than a decimal value that has the size of an integer, all right? But we can round a float and it's going to give us back an integer, so it returns an integer. So what I've done here is I've created a whole bunch of starting data that we can work with. I've got a couple basic pieces of information, doubles, ints. Let's create a float here as well, float. Let's call this f_num1, and we're going to set this to, I don't know, 3.2f, f for float. Okay, so we'll leave that alone. And now what we're going to do is we're going to round this thing. So math.round is going to be our method. All right, well, let's go down. Let's try this out. So in order to do this, I'll just leave my system.out for my math.py for now, just so we can see what it is. You can see it on the screen over here. So if I want to use that math.round, I need to store the result. All of these functions, all of these methods return a result. All right, they're doing some calculations. So they're going to give us some number back in some data type. So we need to make sure that we're storing that in the correct variable type. Otherwise, things are going to break. So math.round, it's going to return an integer. So I have a couple result variables here that I'm going to use. So I'm going to use this result1. We're going to reuse these throughout the life of this little demo here. So result 1 is going to be assigned math.round. And I just need to supply, so you can see that I can give it a double or a float, but when I give it a float, it gives me back an integer. When I give it a double, it gives me back a long. This is a data type we haven't talked about, but basically what a long is, it's an integer that's 64 bits. So it's a really, really, really massive integer, but it takes up twice the amount of space. So we typically don't use it unless we need to. So I'm going to use this float here. And I've already got my variable, so let's use that. So let's say fnum1. So it's going to round fnum1 to an integer and store that integer into result1. Let's display that. System.out.println. Let's say rounded, and now we'll concatenate our variable result1. Now if we run our program, we should get it over here, assuming I didn't make a break. Rounded, and it rounded to 3. So 3.2 rounded to 3. 3.2f rounded to 3. That makes sense because it rounded it properly. Let's make sure it always works. Let's put in 3.5. Now we know proper rounding rules. 5 and up rounds up. 4 and below rounds down. So we should get a 4 here this time. And we didn't. And we didn't because I put 3.5, which is a double. I forgot the f. It's a good error to make. I mean, I swear I meant to do that. Anyways, so we have our rounded 4. So it did exactly what we expected it to do. I'm going to put this back to fnum1. So you can see that we can put actual values in there, or we can use variables. We can even use entire expressions as long as they result in something that it can take, some data type that it can actually use. So that's math.round. The next one is math.ceil and math.floor. They're rounding functions as well. They basically do the same thing, except ceil is short for ceiling, which means it rounds up. Floor rounds down. But you'll notice that both of these guys return a double. So I have to keep that in mind. So I'm going to do the exact same functionality, but this time rounding up and rounding down, but I'm going to have to store it into result2, which is a double this time. So let's try this again. So we're going to have result2 is going to be assigned math.ceil, and it requires a double to be rounded, so I'm going to round dnum2. Okay, so I think this will be the best example. dnum2, which is a value of 4.7. So if we round up, we should get a 5. If we round down, we should get a 4, even though proper rounding would be a 5. Okay, and I'm just going to copy and paste this because I'm lazy. So we're going to round this guy up, and we're not rounding resulting 1 now. Now we're doing result 2. And I'm going to copy and paste this line and do the floor as well because it's basically the same code. In fact, it's the exact same code. I just have to change my output. So I'm rounding up, rounding result2, or rounding dnum2 up and storing it in result 2, displaying that. Now I'm rounding dnum2 down with the floor command, down to the floor, and again storing it back to result 2 and then displaying that. So we have to remember that our programs flow from top to bottom. So that result 2 variable is getting overwritten and overwritten and overwritten. So we run this, and our 4.7 got rounded up to 5, and our 4.7 got rounded down to 4. So it's exactly what we expect it to do. All right, so far so good. So we got 1, 2, 3 down. Number 4, math.pow. I love this one. Pow is short for power, which means a base to an exponent. So we got to supply it with a base and an exponent, which can be doubles, and then it's going to return a double as well. So let's play with this. So we're going to say it's going to return a double, so I have to store it back in result 2. So result 2 is going to be assigned math.pow. Just to keep it simple, let's try 2, 3. So that means 2 to the power of 3. 2 times 2 times 2, which should give us 8. So I'm going to borrow this, and we're going to say power! Exclamation mark. And we run it, and we should get an 8. And we do. And it's an 8.0 because we're storing it as a double. That makes sense. Now, I could just as easily use variables here. So let's use dnum1 and dnum2. So that is taking 3.5 to the exponent of 4.7. And we end up with 360 point a whole bunch of decimal places. Now the question is, could I use integers in there? It said it required doubles. What would happen if I put an integer in there? Let's find out. Will it work? Of course it works. So why does it work? It works because an integer is smaller than a double, and it can be put into that space. All right, so I can put that 32-bit integer into the same space as a 64-bit integer. It just treats the decimal part as 0.0. No problem. Now I got a value of 16. Now let's think about that. I had num1, which is a -2 to the power of 4. So -2 to the 4th power goes -2 times -2. Well, that's going to give me 4. Times -2 is going to give me -8. Times -2 is going to give me 16. So I'm back to positive again. Okay, great. Moving on. Math.pow, done. Math.abs. This has nothing to do with a six-pack. It has everything to do with basic mathematics. Now, you definitely have not come across this yet, but you may come across it later on in your grade 10 mathematics course. Absolute value, most simply put, it's not exactly this, but most simply put, can be described as taking away the sign. So it basically makes every single number that you pass in positive. So if I do math.abs of 7, it's going to give me 7. If I do math.abs of -7, it's still going to give me 7. So it just takes away the negative. That's all it does. So let's do math.abs on num1 just to show this. Now I believe it'll return whatever we pass in. So if we pass in a double, it's going to give us a double back. If we pass in an int, it's going to give us an int back. So we haven't used our result1 for a while, so let's do that. So result1 is going to be assigned math.abs, if only it was this easy to get a six-pack, of num1. Now num1 is -2, so we should get a 2 as a result. Let's find out. And I'm going to grab this guy right here. Change this to absolute. And we run it. Go. REPL is taking its time tonight. There we go. So we got our absolute of 2. Makes sense. We got everything we needed. So -2 became a 2. All right. So we've got round, we've got seal, we've got floor, we've got pow, we've got abs. Now we've got squirt. Squirt, which really means square root. I just find saying math.squirt is much more funny. So math.squirt. So basically we're going to take the square root of whatever number we pass in, which should be a double, and we're going to get a double back. Okay, easy peasy. So we have result 2, 2. Because it's a double, and we're going to assign that math.squirt. Now I can put anything I want here. I could use, a 4, and we know the square root of 4 is, of course, 2. So let's display that on the screen. Remember, I can put an integer in a double safely, so there's no problem with that. Square root. So we should get a 2 as a result here. Great. Now let's try putting a variable in there instead. Let's use the variable of dnum1. So that's 3.5. So this number should be less than 2 because the square root of 4 is 2. So the square root of 3.5 should be less than 2. And it is. It's 1.87. Let's break it for a second. What happens if you try to take the square root of a negative number? Well, num1 is a -1 number, so let's use that. We get nan. Nan is short for not a number, which means it's not a real number. Now, when you get to later parts of math, you're going to learn about something called imaginary numbers, which happens when you take a negative square root. But we're not dealing with that right now. Basically, it means cannot compute it. Not good. So we're going to put this back to, we'll put this at num2. because that's a 4, which would give us a 2 as a square root. Nice clean number. All right, so we got math.squirt. We only have a few left. Max and min basically do the opposite of one another. Maximum will take two numbers and tell you which one's the biggest. Minimum will take two numbers and tell you which one's the smallest. Max and min. Makes sense. So let's check that out. So let's find the maximum and minimum of the numbers -2 and 4. So the maximum should give us 4. The minimum should give us -2. All right. So we'll use result 1 for both of these. So result 1 is assigned math.max, and we're going to have num1 and num2. Going to tell us which one of those two is the biggest. Whoops. Tell us which one of those two is the biggest one. And we're going to copy and paste, because that's what we do. It's going to be max. And we're going to copy and paste this. Whoop. We're going to copy and paste this whole thing, because again, that's what we do. We're lazy. The rule of thumb for programmers is you need to be lazy, but the definition for lazy for programmers is different than everybody else. Our definition of lazy means getting the most amount of work done with the least amount of effort. That's what coding should be. Getting the most amount of work done with the least amount of effort on your computer, ideally. So we have max and min. Let's run it. Let's see if we got -2 for min, and oh, we broke something. What did we break? So line 81, what did I break? System dot, oh, I accidentally typed a V in there somehow. Let's try again. There we go, max of 4, minimum -2. Okay, everything's working out pretty well. Everything's coming up lane. Let's go again. So we got max, we got min. Ho, here we go. Trigonometry. So most of you are in grade 10 right now. Well, all of you are in grade 10 right now. And hopefully you're taking math. And part of mathematics is you learn the basic trigonometric ratios. Sine, cosine, tangent, and all those different things. You'll learn about SOHCAHTOA and calculating angles and side lengths of right angle triangles and stuff like that. And non-right angle triangles too, but basically right angle triangles for now. And what these functions do are they replicate those actions. All right, now if you haven't taken that in math class, we can have another chat about this in class later on. But for now, basically it's just a calculation that will calculate the length of something based on the length of a side of a right angle triangle based on an angle. Okay, so what does this actually, how does this actually work? Well, where are we here? We are going to use this function, math.sine or .cos, .tan, .asine, which stands for arcsine, which means inverse sine, inverse cos, inverse tan, and then a special version of inverse tan as well, which we're not going to get into right now. But what you need to realize is that you need to give it an angle. But there's a catch. The angle must be in a whole new unit of measure that you probably haven't learned before, something called radians. A radian is just a different unit of measure for an angle. That's it. That's it. Now we know degrees. We know that a circle is made up of 360 degrees. Radians are just a different unit. Instead of a circle being made up of 360 degrees, it's measured by pi. So a circle is made up of 2 pi. A half a circle, or 180 degrees, is 1 pi. A quarter of a circle, or 90 degrees, is pi divided by 2, pi over 2. So that's the way it works. Now, you must give it the angle in radians for it to calculate this. Now, we're not used to working in radians, so what if you don't know what that angle in radians is and you want to work in degrees? No problem. The math library also includes a tool to do that. Math.toRadians, and then you pass in your degrees, and you'll get the number of radians to actually do it. No problem. So I've already done this for you. Down here, I've created a variable called degrees, which I set to 90. And then I created a variable called radians, which I calculated from those degrees. So if I change this variable to something else, this will automatically get updated too when I run the program because it's using that variable to make its calculation. Great. So let's use this. We're going to calculate the sine of our angle in radians. Now, if you know the sine of 90, you're going to get a value of 1. Let's go back over here. So let's do this. So we're going to use doubles. So result 2 is going to be assigned math.sine of our radians. Okay. Now, normally you're going to do this. You're going to have your angle stored as a separate variable called radians, but it could be possible that you need to do it right there on the spot. So you could actually do something like this: math.to radians, oops, degrees. You could actually do that right there on the spot, technically, if you wanted to. And it really wouldn't be that much of a difference. You'd actually be saving the memory of not storing the radians variable. But if you needed that variable for anything else, that means you have to be constantly recalculating it, and that's not necessarily a good thing. It's always better to calculate and store and then use that stored value, because chances are you're probably going to need it more than once. Okay, so now we have that. We just need to display our results. We're going to put our sign here. Now hopefully we get a value of 1 over here, or 1.0. And we did. Yay! Trigonometry works. Isn't that fantastic? So the last two I want to talk about is this one here, math.signum. Really what it actually is, it's the sign of the number. Whatever number we pass in there, it's going to tell us its sign. Is it positive, is it negative, or is it a 0? Now it does that using special numbers. So when it gives back a -1, we know that the number we passed in was negative. When it gives back a 0, we know the number we passed in was a 0. When it gives back a 1, we know the number we passed in was a positive. So if I put in a number of -712, the result is going to be -1. And you'd be like, well, how's that useful? It will be more useful later on when we know how to make decisions in our program. So we might have to make decisions based on the sign of a value, like if it's greater than or less than 0, that kind of thing, depending on what you're doing. Okay? So how do we actually do this? We just pass in the value and it's going to give us one of those things. So we're going to call this 2 times. We'll call it on both of these numbers. So it's the first time we should get a -1, the second time we should get a 1. So let's try this out. Result. Sorry, does it return a double or returns whatever we pass in there? Okay, so we're going to use result 1 is going to be assigned math.signum. And we're going to pass in num1. Great. And then we're going to display our results. We'll say num1 sign. And then we'll do the same thing for num2. Okay. And in theory, we should get a -1 for num1 and a +1 for num2. Or we can break our program. Float to int. What is the problem here? Maybe I was wrong here. Maybe it can't take the ints. Let's try the doubles. Let's try dnum1. And I'll update the documentation if that's the case. There we go. Result dnum1, dnum2. And this will probably have to be result 2 now because we're doing it with doubles. Let's try again. There we go. Now we got 1 and 1 for both of them because both of these signs are positive. So let's make this one a negative temper. Actually, we can leave that alone and we can actually just put a negative right there. So it's the negative of whatever dnum1 is, which is 3.5, so -3.5. And we get the -1 there. So it's working the way we expected. Great. And now the final piece to the puzzle, the last one. And this one you're going to use a lot, I can already see it now. And that is to generate random numbers in your program. So pardon the editing, but this is a quick update to the math support or the support library video because we've decided to change the way that we generate our random numbers in the class. So I've updated the example code file that you're looking at right now, but I'm also updating the strategy that we're using. So instead of using what was in the video before that you saw, which said math.random, we're going to use something a little bit more easy to use. It just takes a few more parts, but there's no complex formulas or anything like that involved, so it's less prone to error. You just got to make sure you have all the pieces in line. So looking at the PowerPoint, if I can get that going here, there are three main methods to generate random values in Java. And this website will take you to take a quick look at all three of them, but we're going to use the third version, which is called the thread local random. Now this is a library, and it's a library libraries, as we mentioned before, are basically collections of pre-made code that somebody else made that we can just make use of. And that's what we're going to be doing here. We're going to be making use of the thread local random library, which goes into a whole bunch of fancy details, but we don't need to get into that. So how do we generate a random number? There are 4 steps to generate a random number, and you can reuse a lot of these steps, so you don't have to do all 4 steps every time you want a new random number. You do need to do the first 3 steps once, and then the 4th step you can do as much as you want in whatever product or software you're building at that time, whether that's a game or whether that's something else. You can continually generate random numbers. Now, random numbers are probably one of the most used things in chaotic software like games and whatnot, because that's how we introduce differences in the gameplay every time you play. One time your enemy may choose to do this, another time they may choose to do that, and things like that. You're playing a card game, you might get this card, you might get a different card. So that's how we introduce those types of things. How do you roll dice? Well, you do it with random numbers. Okay, so step number 1. First thing you need to do is decide what is your range of values you want to randomize between. And here I set up 2 integer variables, a minimum value that has a value 6 and a maximum value that has a value 12. Now these are the numbers I want my random value to be actually in between. So 6 and 12. So including those numbers. So it's important that I clarify that. So the next piece we have to do is create a variable to store that randomly generated number. So let's go over to our example code for a second, just to take a look at that, if I can. Now up in here you can see, where is it? First thing I did was I created my min and max values, which you can see right there. I set them to 6 and 12, just like we did in the previous PowerPoint. And then right below there I've created 2 variables to store my random numbers. One's a double and one's an int, because we're going to try and do both, and you're going to see that there's actually a bit of difference between the 2 and the way that they actually execute. So it's important to realize how this actually works. Okay, so that's step 2. What about step 3? Step 3, none of this works unless we've actually told Java to include the library of the tools that we need. So we need to put this line of code right here, import java.util.concurrent.thread.local-random. We need to take this line of code and put it at the very, very tippy top of our program, even above the class line. So you'll see in the example here that I've put it directly above the class line, a little comment that says this line is needed to use the random generation technique below. So none of it will work unless you have that line of code in there. It just basically includes the library in our project. So it's probably the most important piece. All right, so that's the 3rd step. The final step is just to use it. And it's actually a fairly straightforward command. Now here's the thing. I don't expect you to have this memorized, just like I don't expect you to have step 3 memorized, so you feel free to copy and paste them. But I think what you're going to find is after you've done this a few times, you're probably going to memorize it by accident. Okay, so for now, just copy and paste it, read what it says, and then you're going to realize, oh, I understand this now. Now here, what we're doing here is we're storing the random number in our random variable. Now I'm storing it in that int random num here. So this is the command, thread local random dot current dot next int. This is the magic here, dot next int. It gives me the next random integer between this range. Now notice the range I put, minimum and max plus 1. Because the way it actually randomly generates, it actually generates a number from minimum up to, but not including the value we put in second. So if I add 1 to that, that means I'll actually get my maximum value. So it's actually saying, if we were putting in the literal numbers, we'd actually be putting in 6, 13. If I wanted a random number between 1 and 100, I'd use 1 and 101. 1 and 10, 1 and 11, things like that. Now here we have the actual variable. So I just added 1 to my variable. Now you see we're getting the next random integer. There's actually other commands too. There's next double, next float, And there's actually a next Boolean as well, which is really cool. You don't need any minimum or maximum for that. You just need to say next Boolean, and what you're going to get is a random true or false value. This is really good for flipping coins, for deciding who gets to go first in a two-player game, things like that. So let's put this into actual action and see how it looks in our program. So here is an example of a functioning program, and I'm going to put it into the actual code layer again. But anyway, so here we have our library that we're importing. There's our minimum and maximum values. There is our two variables to store our randomly generated values. And now down below, I'm actually generating those numbers. Now, I want to point something out though. So this is going to give us a random number between 6. Now imagine this, 6 comma 13 is really what's being put there, right? So remember, that second number is not included in the generation. So that means I'm going to get 6 up to 12. Okay. Now next double, this is the same thing as 6 comma 13 again. But what that means is that, remember, I want to go up to 12, but since I put that number 13, that means it's going to go all the way up to, but not including 13. But these are decimal values. These are doubles. That means like 12.5 is a perfectly valid result here, even though that's bigger than our actual maximum. So that's something we have to keep in mind. So if you don't want it to get that high, you may not want to put in the +1 when you're generating a random double. So keep this in mind when you're doing this. And I'm going to show you this in the actual code when we get it running. Let's go take a look. So down below, way down here, I've actually already done the work. I've generated a next double and stored it into random num, and next int and stored it in random num 2. So let's run the program a few times and see what kind of random numbers we get. And we should get different values every single time. So the first time we ran it, we got a random integer of 10 and a random double of 9.25, a little bit more. Let's see if we can get a number that's above 12, just to show this. So you can see that we're getting different numbers each time. Go again. Come on, Java. We'll give it a couple more tries and see if we're successful or not. It did actually happen while I was testing before I made this video, so we'll see how our luck is. Right now, it looks like it's not panning out too much, but that's okay. Oh, so close, so close. 2 more times. We'll see. Come on, Java. Oh, there we go. We did in our next one. So we can see that we actually went above our maximum there, because remember, it's generating a number from 6 up to, but not including 13. So anything below 13 is perfectly valid. Now when we're talking about integers, well, the next thing below 13 is 12, so we're good. But when we're talking about doubles, the next thing below 13 is 12.99999999999 forever, right? So you have to be conscious of this when you're choosing to create your program. So that's it. That's all there is to random numbers. So 4 steps, one more time. So the first thing we have to do is we need to create our minimum and maximum values. Boom. Second thing we need to do is create our variables to store our random numbers. And then the third thing we need to do is import the library. And finally, the last thing we need to do, and we can do as repeatedly as much as we want, is generate our random numbers. Okay? And here we're using variables, which you should always try to do, but sometimes you may just be using literal values. It depends on the situation. All right, that's it. Thanks for listening, and good luck.